example number 3. So example number 3, now we get to use this relationship between logs and exponentials. So we're asked to solve the following: log of x squared equals 2. Okay? Same situation, right? I've got this x squared, it's really like a composite function. Right? I have x squared plugged inside the logarithmic function. So one thing that I'll do is I'm going to take this little 2 and toss it to the front, and I'll end up with 2 log of x equals 2. Well, now if I divide both sides by 2, I get log of x equals 1. Okay. Now this is a little different than the way it's written in your textbook. So, remember the relationship here is b to the y equals x, or remember that we have a base 10 here, so I've got 10 to the 1 equals x. So what's x equal? 10. Now, so we already know what the answer is by using this relationship, right? So, if I do it this way, I only have half the answer. I have what we call the principal root, because technically we're dealing with the square root. And when I toss that 2 to the front, I'm kind of ignoring the negative 10 solution. And I'll explain that in just a second. So another way that we could do this problem is that we could just leave it the way that it is. So if I were to start over and say log of x squared equals 2. See, if I were to write it like that, I could rewrite this as log, because remember this is base 10, right? Log base 10 of x squared. Now I could rewrite 2 as a log base 10. So now how would I do that? So 2 equals log base 10 of something. Now what that means is, and I don't know what I plug in here, but that's the same relationship, right? So we're going to have b to the y equals the stuff. Or 10 to the 2 equals the stuff. Well, what's the stuff? Well, it's just 10 squared or 100, right? So what I could do is I could say log base 10 of 10 squared. That's the same as 2, right? These two things mean the same thing. Now if I do it this way, I could think of it in terms of this b to the y equals x business again, and I'll end up with x squared equals 10 squared, which means x squared equals 100, and when you take the square root of both sides, you get plus or minus 10. So now that we're dealing with logs, by the way, how many of you guys thought I did something wrong on my first attempt? Well, if you read the textbook, you would know that, right? But if you didn't read the textbook, what I did was correct, right? It was one of the solutions. It was only 1/2. How could I verify I verify? How could I verify that if I have all of the solutions? Anybody? Yeah, graph it, right? So you probably would have guessed that because you see that I pulled up my graphing calculator. So it only takes like 10 or 30 seconds or whatever to plug it into your graphing calculator and see where it goes. Okay? So you should always double check your answers on your graphing calculator. That's why they let you use them on the ACT and the SAT. But you got to know how to use them. So everybody get your calculators out. And we're going to plug in, what was it, log base x? Log base 10 of x, right? Oh, it was x squared. I apologize. So we got to do the x squared thing. And we're interested in when that equals what? 2, right? That was the original. And so remember, we said that we could solve an equation by graphing the left-hand side of the equal sign as one function and the right-hand side of the equal sign as another function. And then what do we look for? Where they intersect, right? So I'm going to graph this. Now my solutions say that we have two possible solutions. We could have plus or minus 10. And so what I need to do is when I do my window here, my x values need to go from like negative 11 to 11 because that's outside of the x parameters. But now my y values, we know that it has to intersect 2. So I'm going to choose like a y min of 1 and a y max of like 3 because 2 is right in the middle of those. And then I'll get a graph like this. And everybody that has a calculator should have a calculator in their hand. Here you go. Startled them a little bit. All right, so now what we want to do is we want to check out where they're intersecting, right? So if I come in here and I hit 5, now what do we know that the answer is already? 10 and negative 10, right? So I'm going to play along and just kind of graph this curve and get to where it needs to be, and I think it's at negative 10. And so now remember, when we're looking for the intersection, we just want to get that little crosshair thing as close as we can. Hit enter, hit enter. And now I've got like negative 10. Can you guys see that in the back? Now if I do it again, if I hit second trace, and you guys are doing this as well on your calculators, and now I got to go all the way back over here to positive 10. This may take some time. I always feel like there should be like Jeopardy music playing. And it's 10. Okay? Does that make sense? Any questions? You guys got it?